Welcome to The Explainer. Have you ever wondered how massive companies run thousands of different apps on their servers without everything just crashing into a chaotic mess? Well, you've come to the right place. Today, we're going to break down the two key technologies that make the modern internet possible: containers and virtual machines. We'll look at what they are, how they're different, and which one you should be thinking about for your next big project.
All right, let's jump right into the big problem. So picture this. You've got one super powerful server, but you need to run your company's website, its database, and some new analytics tool all at the same time. How do you keep them all separate so if one of them has a bug and crashes, it doesn't take everything else down with it? This is the fundamental challenge that both VMs and containers were born to solve.
To really wrap our heads around this, we're going to use an analogy that will stick with you. Just imagine your physical server is a big, empty plot of land. You want to house different families, or in our case, different applications on this one plot of land. So, how do you do it? At the end of the day, the challenge is all about efficiency. How do you squeeze the most value out of your hardware? You've got this expensive plot of land, your server, and you want to use every single bit of it, but without your families, your applications, getting into arguments or breaking each other's stuff. So let's explore the two main blueprints for building on this land.
And that leads us to two totally different philosophies. The first approach is like building a complete, separate, standalone house for each and every family. The second approach, it's more like building one giant apartment complex and just renting out individual rooms. And these are our two contenders: virtual machines versus containers. So first up, let's talk about the classic, the heavyweight champion, the virtual machine. This is our build a whole new house for each app strategy. And it's been the industry standard for a long time and for some very good reasons. So what is a VM, really? Think of it as a complete computer, but made of software. It runs as a file on another computer. It gets its own virtual CPU, its own virtual RAM, and this is the most important part, its very own, complete, independent operating system. That means you can run a Windows VM right on top of a Linux server, no problem. It's literally a computer inside your computer.
Now this diagram really shows you all the layers. Down at the bottom, you've got the physical hardware. On top of that, the main host operating system. But the real magic is that layer in the middle, the hypervisor. The best way to think of a hypervisor is as a traffic cop for your hardware. Its entire job is to slice up the real hardware and hand out dedicated pieces to each virtual machine, tricking each one into thinking it has the whole machine to itself.
So the big thing to remember here is that each VM is a heavyweight package. It's the whole house, right? It's got the foundation, the plumbing, the electrical wiring, and the family living inside. And this makes it incredibly self-contained. It gives it a really strong, thick wall of isolation from its neighbors.
Okay, so if a VM is like building an entire house, what's the alternative? Well, this brings us to the more modern, super lightweight approach that has totally taken the tech world by storm: containers. This is our renting a room model.
A container is just radically leaner. Instead of pretending to be a whole new computer, it just packages up one application and only the stuff it directly needs to run. And here is the absolute game-changing difference: it does not have its own operating system. It shares the core of the host server's OS, which is called the kernel. It's kind of like all the apartments in a building sharing the same foundation and plumbing.
And you can see the difference right here in this diagram. The stack is so much shorter. You've got the hardware, the host OS, but then instead of that heavy hypervisor, you have a really lightweight container runtime. You've probably heard of Docker. Think of the runtime as the apartment building's manager. It's not building new foundations, it's just managing who gets which room and making sure they don't bother each other. And notice what's missing. All those bulky guest operating systems are just gone. It's so much more efficient. This super lean structure is really the secret sauce. By getting rid of that redundant operating system in every single package, containers become incredibly fast, efficient, and easy to move around. It really is like the difference between moving an entire house versus just packing a suitcase. You're only bringing the bare essentials your app needs to do its job.
All right, so we've seen the two different blueprints. Now let's put them side by side. This is where the real trade-offs start to get super clear, and you really see why you'd pick one over the other.
So what it all boils down to is this: you're almost always making a choice between the fortress-like security and isolation you get with virtual machines versus the incredible speed and efficiency you get with containers. You're usually trading one for the other.
This table lays it all out pretty clearly. Let's just walk through it. First up, size.
I mean, look at this. VMs are huge. We're talking gigabytes because they have that full OS. Containers? Tiny, megabytes. That massive size difference leads directly to startup time. A VM can take minutes to boot up its operating system, while a container can start in seconds, which of course means resource usage is really high for VMs and super low for containers. Now, here's that trade-off we talked about: isolation. It's incredibly strong in VMs, like a house with thick brick walls. In containers, it's more moderate, kind of like apartments sharing a wall. And finally, portability. Containers are the clear winner here. They're so much easier to move between different computers and different clouds.
So when you need to fire up a new virtual machine to handle, say, a sudden burst of website traffic, you are thinking on this time scale. You're waiting for an entire operating system to boot up from scratch, just like your laptop does.
And this is the timescale for a container. Because it's just starting a simple process on an operating system that's already running, it can spin up almost instantly. And this difference isn't just a little bit faster, it is a total game changer for how you design and scale modern applications.
Okay, enough with the theory. Let's talk about how all this stuff actually plays out in the real world. When would you actually choose to build a house instead of just renting a room? So back in the day, hosting a web application meant you built a whole little village of VMs. You'd have one house just for the web server, another house for the application logic, and a third separate house for the database. And yeah, it's incredibly secure, but think about all that waste. Each of those VMs is running an entire operating system, and most of the time it's just sitting there, doing nothing. And what happens when you get a sudden flood of traffic? Well, building a whole new house takes minutes, and by then, your customers might have already given up and left.
Now, contrast that with a modern software development pipeline. This is where containers just absolutely shine. A developer commits some new code, and a temporary container instantly spins up just to compile it. And then, it's destroyed. Another one pops up to run all the automated tests. Then, it's destroyed. This disposable, lightning-fast nature is something you just can't do efficiently with big, clunky VMs.
But here's the big twist. This isn't always an either-or situation. You might be thinking you have to pick one, right? The house or the room? Well, what if you didn't have to choose? What if you could have both?
And this, right here, is exactly how most of the modern cloud actually works. The winning strategy, it turns out, isn't to pick one over the other, but to combine them. The most common setup you'll find today is a big, secure virtual machine acting as the house, and then inside that house, you run lots of small, lightweight containers as the rooms.
This hybrid approach really gives you the absolute best of both worlds. The virtual machine provides that secure plot of land with a really strong fence around it. This is super important in the cloud, where one physical server might be hosting applications from 10 different companies. The VM makes sure they can't mess with each other. Then, inside that secure boundary, you can use containers to efficiently run all your rooms, scaling them up and down in seconds. You get the security and the speed. You get it all.
And so we come full circle. You've got the secure, isolated house of the VM, and you've got the efficient, flexible room of the container. Now you know that most of the time, the modern answer is to actually use both, but you understand the why. So the next time to use an app, think about the layers underneath. You're probably sitting in a room, inside a house, on a shared plot of land. The question isn't just about building a house or renting a room anymore, it's about how to design the most efficient city possible.